In this segment of our module, we will cover the nomenclature and construction of a typical parallel shaft single reduction gearbox. The reason behind the name will be quite apparent in a moment. For the purpose of this discussion and later segments, we'll be using this gearbox as a typical example of the many gearboxes that you will run into during your career as a machinist. The main component of the gearbox, as seen in this view, consists of the case itself. The case is generally split horizontally, as is being pointed out here, at the center line of the shafts. The upper half of the case, here, acts as a cover for the gearbox internals. The lower half of the case structurally supports the gearing within, and may, in some cases, act as a reservoir for the oil required in lubricating the moving parts of the gear. The plate being pointed out here covers the blind end of the high-speed shaft and bearing. And an air baffle on the open end of the high-speed shaft breaks up the air flow from the high-speed coupling, which creates a slight vacuum and prevents oil from being sucked out of the case. Air baffles also help to prevent the entrance of foreign materials into the case. In some gearboxes, you may expect to find the low-speed shaft so equipped. The upper half of the case is equipped with a breather to ventilate the gearbox. This inspection plate can be easily removed to inspect the internal gearing, eliminating the need to remove the case cover. Nameplates, like this one, are sometimes useful in identifying the gearbox as to its type and speed reduction. Serial numbers are sometimes quite necessary in ordering replacement parts. Directional arrows, as indicated, show the direction the gears must turn in normal operation. This item here is a small gear pump, driven off the low-speed shaft, used to circulate the oil necessary to lubricate the bearings and gears within the case. As some gearboxes are lubricated by central lubricating systems, you will find that some gear units are not so equipped. Water is passed through tubing within this oil cooler to maintain the oil at operating temperature. This part is an oil filter. Within the filter, there is a filtering element that separates solid contaminants from the lubrication oil stream. The oil level within the gear case may be checked visually by observing the level in this sight glass. And oil may be added to the reservoir by removing the inspection cover. Oil system pressure in operation may be observed on this pressure gauge. And the oil pressure may be adjusted by this pressure relief valve, mounted in the oil passageways, cast into the upper half of the case, as is shown here. Now, having removed the top half of the case, you can see in its dome an oil header with a series of holes drilled in it, which serve as nozzles to spray oil onto the teeth of the two gears. And with the cover off, we are able to see in detail the internals of a simple reduction gear. The gears are of the herringbone design. The combination of the right-hand and left-hand gear teeth angles, as you can see, eliminates any axial thrust on the bearings themselves. The larger of the gears is known as the gear wheel, although it may be better known as the bull gear. The smaller of the gears is known as the pinion gear. On this unit, the pinion gear rotates 6.16 times faster than the gear wheel. Since in this assembly there are only two gears, the gearbox is known as single reduction. The high-speed shaft, being identified by the workman, is the input shaft and is coupled to the driver in operation. The low-speed shaft, then, is driven by the gearing and is coupled to the driven equipment. The driven equipment then turns at a speed 6.16 that of the driver. The two shafts are mounted parallel in the lower case, giving the gearbox the other half of its name of parallel shaft gearbox. The two gears are carried on 4 bearings. These two support the high-speed shaft and pinion gear, while these two bearings support the bull gear and low-speed shaft. This gear case cover is fitted with dowel pins which fit tight in the cover and loosely into holes in the top halves of the bearing shells. These pins prevent the bearing from turning, and in the case of the high-speed shaft bearings, from moving axially in their fits in the case. Since the low-speed shaft bearings must locate the bull gear in the case and absorb any axial thrust that may develop in the reduction gear, they must be positioned more precisely, axially, in the case. The purpose of these small pins is to prevent the bearings from moving toward the bull gear. The shoulder, machined into the bearing shell, fits against a machined surface in the gear case and prevents the bearings from moving away from the bull gear. Therefore, the correct thrust clearance is maintained during operation of the gearbox. Removing the upper half of one of the low-speed bearings, note that the bearing is of the split sleeve design, babbitt-lined. The low-speed bearing is also designed with a thrust shoulder, being pointed out here. In this view, we can see the thrust runner that is machined on the side of the gear wheel. When assembled, note that the thrust shoulder on the bearing, in conjunction with the runner on the gear, maintains the running position of the gear within the case. The high-speed shaft bearings are plain bearings, babbitt-lined. No thrust shoulders are required on this bearing, as the teeth engagement of the two gears maintain the running position of the pinion gear. Lubrication canals are generally cast in the gear case to channel oil to the bearings and to the spray tubing in the top half of the case. Lubricating oil is pumped into the oil channels and enters the bearing through holes drilled through the bearing itself. The collector grooves in the bearings provide a channel for the return of oil to the reservoir after it has passed through the bearing. And labyrinths, machined in the outboard ends of the bearing, prevent the leakage of oil out of the case along the shaft. That's the basic construction of a parallel shaft single reduction gearbox. Although it won't be identical to other models that you will run into, you'll find many similarities. What you learn here will make it easier for you to handle them. In our next segment, we'll show you how to take a gearbox like this apart. But first, complete exercise number 2 in your